your Monday, December 10th math homework video over solving equations on your student notes. And be sure that you put this in your journal so you can use it as a reference on your test. So moving on to the handout, solving equations, student notes. Read over this, please. We covered most of this in class last week when we were working with concrete models because you were also curious as to see why we were talking about squares and circles. And now you know why. And now you know the steps in solving one-step equations. We're going to talk about two-step equations. And this example, the only thing that I'd like to point out, I'm not going to work it out, it's already worked out here for you. We're teaching you guys to subtract or do the opposite vertically, and I have that highlighted here in red where the example doesn't correspond. So, last but not least, check your solution. We have a gentleman over here rocking out on the guitar. He's so happy that he checked his solution and he got it right. Always check it. That way you know without a shadow of a doubt that you got it wrong. All right, sorry, you got it right. So let's look at this first example problem. We have 2x minus 3 equals negative 7. I write kind of big, so I'm going to rewrite the problem so you can see it worked out. But please just go ahead and write it on your sheet there. Very important. If you do rewrite a problem, you make sure, check it twice, that you write it down correctly. Those negative signs are very easy to miss. So first things first, we are going to start isolating the x. We're getting the variable by itself, and we have a minus 3 attached to it. I'm going to get rid of that first. So we're going to add 3. And remember, what we do to the left, we must do to the right side. Solving that, moving on down, negative 3 plus 3 goes away. You're thinking with your two-color counters, you know that you have 3 0 pairs there, and that goes away. So we're left with 2x equals negative 4. Well, we're not finished because we still have this 2 attached to the variable. It's still not isolated. Isolated means that it's alone by itself. So in order to undo this multiplication of 2 times x, we must divide by 2. And if we do it on the left, we must do it on the right. Now we're left with 2 over 2. Well, in simplifying 2 over 2 as a fraction, that leaves us with 1. So we're left with 1x, and that's our goal. We want to get 1x on either the left side or the right side of the equation. In this instance, it's the left side. Now we have to solve. Negative 4 divided by 2 is negative 2. Okay, but I'm not finished. Just because I have an answer, I am not finished. I have to go back and evaluate x at negative 2 to see if it works in my equation. So in doing that, I am going to say 2 times negative 2, substituting that for my x, minus 3 equals negative 7. 2 times negative 2 is negative 4, minus 3 equals negative 7. We're looking good. Negative 4 minus 3, negative 7 equals negative 7. I have balance. I have negative 7 on this side, I have negative 7 on that side. Therefore, without a shadow of a doubt, 100% certainty, x equals negative 2 is my correct answer. Moving on to example number 2. I have 4 equals 3x minus 8. Okay, well, the x's are on the right side of the equation, but that's no big deal. We still handle this the exact same way. I have a plus 8, negative 8 attached to my x, so I'm going to get rid of that first by adding 8 on both sides. I draw a line here so you can make sure what you have on one side you have on the other side. Negative 8 plus 8 leaves me 0, so I'm left with 3 x's, and I've got 8, 9, 10, 11, 12. X equals 3x. I have to have the x isolated. I have to have it by itself. I have 3 times x. I have 3 x's. So in order to undo this operation here, I must divide. So I'm going to divide the right side by 3, and then I'm going to divide the left side by 3, because what I do to one side, I must do to the other. 3 over 3 gives me 1. That's my goal. I want 1x by itself, and 12 divided by 3 gives me 4. I am not finished, and neither are you. So we have to evaluate 4 to see if it balances. 4 good to go. Box in your answer. Now, going back up to the last example, I want you to please pause the video and work this on your own. Please come in with the steps as you were taught to do, procedures for the solving the problem, and then also check and see if your work is correct. Pause now and please work this problem. Go back and look at my example if you do not understand what to do. Okay? So the answer to this problem is, after you pause the video, I'm so sure, it's negative 2.6 equals x. And if you check your solution and you balance, you already know that your answer is right. Moving on to the next page. Don't forget, I said it over and over again, that the equal symbol is equality. The left and right side. It means it has to be equal. Here's an example problem for you. Once again, you can use that as a reference. I'm going to go straight into working the problem. It's basically the exact same, except in this instance, we're throwing fractions in. Yuck, yuck, yuck. I know that's what you're thinking, but it's not a challenge that we cannot overcome. The first problem, I like to rewrite my problems whenever I have a fraction like this, because I know in front of this x is a 1. So I'm just going to rewrite it. A half of x minus 3 equals negative 1. Okay? And if you care to rewrite it this way because it's easier for you, that's perfectly fine. I have half of an x minus 3. I'm going to undo this subtraction first by adding 3 to the left side, adding 3 to the right side. I'm going to see how far that gets me. Okay? I have a half of an x still, and I have to get x by itself. And then I have a positive 2. I'm not finished. I have a second step to this equation. I have to undo this. And in order to undo multiplication, I must divide. Guess what, guys? You remember when you divide fractions? A half divided by a half. We have a couple of different ways that we can solve this, but one way is to flip the second fraction and then just multiply. 1/2 times 2 over 1. And guess what it gives me? It gives me 2 over 2, which is indeed 1. Well, wouldn't that be a great tool to use over here to figure x by itself? So I have 2 over 1. All right. Okay, guys, so we're going to finish up solving this problem, and we proved over here that we're left with 1. So we do indeed isolate the variable by itself, and we're left with x equals 2. But we're not finished because we have to check to see if our solution is correct. So I'm going to go back to my original problem, and I'm going to say 2 over 2 minus 3 equals negative 1. 2 over 2 is 1, minus 3 equals negative 1. And so continuing on and looking at this, I had to pause the video for a second, but we have negative 2 equals negative 1. Well, this is not balanced, guys. Look, negative 2 is not equal to negative 1, so I know that my solution of x equals 2 is not correct. So let's go and look and see where we made a mistake. So I added 3 to both sides, okay? 3's cancel, I'm left with a half x equals 2. I'm happy with that. Oh, here's the deal. Look and see what happened. I did multiply by 2 on this left side, but I did not multiply by 2 on the right side. So this is how mistakes happen, and what you have to make sure that you do. So 2 times 2 is 4. Now let's reevaluate this again. So we have x, and we're going to substitute our 4 over 2 minus 3 equals negative 1. 2 minus 3 equals negative 1. Negative 1 equals negative 1. Now I'm in balance, and I know with 100% certainty that 4 is correct. And that is an example that just proves to you why you need to check and make sure that you have the right answer. Okay, so I'm going to let you work example number 2 and example number 3 on your own. So you can pause the video and work it, and pause, work it out. All right, so now you see, if you worked it and checked your work, you know that you have the right answer. But just in case, example 2 is 36 equals x, and example 3 is negative 20.8 equals x. All right, guys, well, this is your example problems for 2-step equations. We're going to do more practice in class this week. If you have any questions or if you don't understand anything or would like to work some additional practice problems, please let one of your teachers or your teacher know. Hope you have a good night and see you tomorrow. Bye.